Okay, so we learned about the unit circle and we learned about degrees, and we're learning now about how radians are a whole different way of measuring angles. What I'd like to do is I'd like to go back to that unit circle diagram with the degrees, and we're going to double check and make sure you understand where all of those are. Then we're going to convert them to radians so that you can see how they compare. Keep in mind that on a unit circle, X is the beginning spot on the right-hand side. And we start with 0 degrees, then we move counterclockwise up to 90 degrees, then we counterclockwise back to 180, which is a half a rotation. Then we keep moving down to the bottom, which is 270 degrees, and back up to 360. Now, these are marked in quadrants. These quadrants are all worth 90 degrees. So we're literally just counting by 90. So it's not hard to figure out what those are. You're just going in 90-degree blocks. For radians, what I want to do is just write some stuff down under here so that you can make sense of it. And the one thing that you need to know is that we're going to start with the fact that to do a radian conversion of these unit circle values, you need to know one basic fact. And that is that one full rotation, which is a complete circle, 360 degrees, is equal to 2 pi radians. And that is going to be crucial. So one full rotation, which is 360 degrees, in degrees is equal to 2 pi radians. So knowing this fact right here is going to help us get the other 3 spots. So 2 pi is where a full rotation is. So under 360, put 2 pi because that's the radian conversion. From there, we're going to figure out what the other, 4 are. This one's a little easy because at 0 degrees, you haven't started yet, so that's just 0 pi. So that's easy. All right, so these are in pi's, and 2 pi represents 360. 0 pi represents 0, so this is the beginning and the end. Now we're going to look at these 3 positions. Now, if you look at the quadrants, they break this into fourths. Okay, so this is like 1/4, 2/4, which is 1/2, 3/4, and then, of course, 4/4 takes us right back to full circle. So if I want to know what 1/4 of 360 is, I would do 1/4 times 360, and that would give me 90. For radian conversion, it's the same thing. I know that 90 is 1/4 of 2 pi. This is what 90 degrees would be. It is 1/4 of the way around the circle. And in order to do this, I would put my 2 pi over 1 and get 2 pi on top. 1 times 2 pi is 2 pi, and 4 times 1 is 4. And reduce, and that gives me pi over 2. So pi over 2 matches my 90 degrees, and that is my radian measure for 90. The next one I want to do is 180. 180 represents 2/4, or 1/2 of a rotation. In which case I'd put this over 1, and this would be 4 pi over 4, which reduces to just pi. So this is worth 1 pi. You could also have done 1/2 of 2 pi, which is 1 pi. This one is pi radians. Then keeping it into fourths so that you see it. So this is 1/4 of a rotation. I got pi over 2. 2/4 or 1/2 of a rotation. I got pi. Now I'm going to do 3/4 because this is 1, 2, 3 quadrants. So 3/4. That's of 270. Put that over 1. And this gives us 6 pi over 4, which when you reduce 6 pi over 4, you get 3 pi over 2. And so we have our radian to degree conversion for our unit circle. So these are our basic unit circle quadrantal angles in both degrees and radians. But what happens when they live in here? What happens when it's just a quadrant 2 angle and it's not something that's an easy fraction of the circle? Well, that's where we do a different kind of conversion. So I'm going to split this up, and I'm going to give you one more slide that has the conversions for all of the other measures on it. But for right now, this is great for you to have for our conversions from radians to degrees for your quadrantal angles. And I will see you in a second to do the last one.